Australia has so much of Antarctica. Obviously, no one would allow mining. We'd expect it to be in southern Africa, but unfortunately the belt just tips around the bottom of southern Africa here, and there's not much gold there. What I want to try and get across to you, we'll have a break in a minute because I'll be talking for a while, do another 10 minutes, and then we'll just have a break for you to talk in your own language and so on. But what I'm trying to get across to you is that these orogenic gold deposits are not something, it's not a granite coming up here and we're heating up the crust and we're producing it. Not some local thing. This is big scale, right? This is big scale. When you look at the gold occurrences in Egypt, for example, and as you go down towards the Sudan, which presumably where a lot of the Nubian gold came from across that border there, you can see the strings of gold occurrences all the way through the terrain. So the gold is actually everywhere. If you look on the other side of the Red Sea, there's gold everywhere, little gold occurrences everywhere. And the reason for this is that gold, the gold occurrences are just a normal part of this orogeny. When you get an orogenic belt, the gold has to form at some stage in it. How much forms is the question. So what's happening, you've got to look really big scale. You can't go look at a gold deposit and do all this detailed research. You've got to stand back, look at the district, the province, and then at the big scale. And what we find when we look at the tectonic setting of all these gold deposits, in the Precambrian, there were probably big mantle plumes coming up. They came from the core mantle boundary, they overturned the mantle, produced an enormous amount of heating, they probably flattened out subduction zones. So we see, if we look at the gold distribution in the Precambrian, the time distribution is strongly related to plumes. So they probably had a big impact in the early Precambrian. Then we see cases where people think that the bottom fell off the subduction zone. All these things bring what we call a asthenosphere up into the system. They bring hot mantle up to heat up the whole of the crust. In China, as I'll show you in a minute, the Chinese deposits of the Shandong Peninsula form when a great big piece of the lithosphere. The lithosphere is a sort of rigid part of the mantle that's had a lot of magma extracted from it, and it's normally under big cratons. It could be 200 kilometres deep, and the bottom fell off of this because we had subduction from this side, that side, and out of the ball. We had 3 subductions at once, and that dropped the bottom off the lithosphere. In the mother lode in California, there's a lot of tectonics work going on. They think this slab, the downgoing oceanic slab, rolled back and again lets the stratospheric heat in to produce something like the mother lode here. So what I'm trying to get at is that the gold is just part of the development of mountain belts or metamorphic belts or orogenic belts, whichever you like to call them, but something special happens to produce the big ones. You have an extra heat coming into the system. Ore deposits are all about thermal energy. You've got to get hot fluid moving through the crust somehow, so you need a thermal engine to drive it. That can be porphyries or granites at upper level, but these big deposits that are forming down deep in the crust, it's got to be something very deep. And this is why I think we don't know exactly what the fluid is, because it's coming from down here. This is a case in China, so through a whole lot of work that people have done through looking at things like kimberlites and doing other imagery, we can see that the normal craton, so if we look down the Yangtze craton here, the normal lithosphere is up to 160 kilometres kilometres deep. We can see up here 150 kilometres deep. And then here, you can see around here down to 60 kilometres deep. So 100 kilometres of the lithosphere has fallen off. And that's because we've had sort of subduction from here, subduction from here, subduction from here, and that's eroded the bottom of the lithosphere. And then you can see around the edges of this is all a craton, whole lithosphere here. Around the edges, the fluids come up, and everywhere around the edge of that craton where all this has gone, we've got these gold deposits. Don't find any down here, don't find any up here. They're only where that lithosphere's been eroded away. So they're a situation like that, so the gold deposits are coming around the edge, and if we didn't have that happen, we wouldn't have the gold deposits. So there's one example that shows us that something very large scale is causing this. The big orogenic gold systems in China are occurring in the Shandong Peninsula over here. This is Western Australia, where I've been working mostly, and this is just we won't worry too much about it. This is just a thing called epsilon neodymium. It measures the age of the pre-existing crust, basically. So these dark colours are telling us this is very old crust, old, cold crust. The gold deposits formed at about 2.7 billion years ago, 2650, 2640, something like that. You can see the edge there. This is the biggest lithospheric boundary. Under here, the lithosphere would have been quite thick and cold. See a bit of a rift through it there. That little rift in there. We can see this big boundary down here. Potentially there's another boundary out here, but can't get very much information over here. But all the really big gold deposits of Western Australia lie in a belt along the side of that boundary or along this boundary in here. We can see a very thin lithosphere up in here, and it's interesting, this is where the few volcanogenic massive sulfides, so this is almost oceanic crust up here, and the volcanogenic massive sulfides we see in Western Australia actually occur up in this area where we see that very thin lithosphere just in there. But the important thing is, if you want to find a big gold deposit, it's along that line there or along something out here. And the only world-class deposit in the whole, there's lots of gold deposits. You see these little black dots around. I think they are, or they, I think they're gold. Anyway, the gold deposits are all the way through here. This rift, so we've got thin lithosphere here. Something's happened. It's thin. We've got more heat there, basically. We've got a lot more heat there and here into the terrain. The only world-class gold deposit in this part, this whole half of Western Australia occurs in there. And it's 5 million ounces as against something like 75 or even 100 million ounces at Kalgoorlie over here. So this big scale tectonics is very important in terms of gold. It's important in terms of the porphyries and other things as well, but in this case it controls, so this is very hot under here, it's telling us very hot under there, it's less hot under there, so a lot of thermal energy and a lot of fluid being driven up this zone, particularly near this big structure. Alright, that might be a good spot if people want to ask questions. I know people don't like asking questions in an audience. This is something that is always the case. So if people want to ask questions, these are the 5-minute chance to just ask me something. And if it's a good question, which it usually is, people are scared to ask, but often it's something that I wish someone would ask, because then I could explain something a bit more. But